Continuing on with these sample test problems, problem 3 asks me, given a certain n and p within a binomial population, find the mean and standard deviation of the sampling distribution. The mean is incredibly straightforward. I really just need to spit back whatever the population value is, and that's my guess for the mean. So in this case, the mean should be p equals 0.75. If I now am looking, and really it's not p equals, it's mu sub p. When I look for the standard deviation, sigma sub p, there we have the equation where we need to take square root of p 1 minus p over n. So in this case, we're going to need to put into our calculators the square root of 0.75 times 1 minus 0.75 over 400. When I put that into my calculator, second root, make sure I'm still under the root with a new parentheses, 0.75, and that new parentheses, 1 minus 0.75, and that parentheses divided by 400, finally end the parentheses that takes me out of the root. If all of that is done correctly, I should be getting 0.02165. Looking back at the question and how they asked me to round, they say round to 4 decimal places. So if I'm going to 4 decimal places, 1, 2, 3, 4, I'm going to this decimal place. Since the 5 is 5 or larger, my answer is going to be 0.0217. Number 4 says random samples of size 110 were taken from a binomial population with p equals 0.32. Approximate the following probability. If I want to be between 0.31 and 0.35, I'm going to need to find z-scores for each and then take larger p-value minus smaller p-value. So the first z-score is going to be based on 0.31 minus the population, 0.32, over the root of the population, 0.32, times 1 minus that population, 0.32, over the given n, in this case 110. I'm then going to need to do the same thing for 0.35, 0.35 minus 0.32, over the root of 0.32, 1 minus 0.32, over 110. So I'm going to put each of these into my calculator. When I put the first one in, parentheses, 0.31 minus 0.32, end parentheses divided by the root of new parentheses 0.32, end parentheses, new parentheses, 1 minus 0.32, end parentheses divided by 110, outside of the root to end parentheses. Again, I know it's very boring as I type everything in and say how I'm doing it, but this is where students mess up the most, is making sure everything's done to the root and then it's properly entered into the calculator. If I do enter it properly, this first one should give me a z-score of negative 0.2248, which rounds down and just gives me negative 0.22. When I try the same thing for 0.35, after putting it in my calculator, I get a z-score of 0.6745. Again, I'm going to round down because this 4 is less than 5, so I'm just going to look up 0.67. So where I'm going to start is on the negative side. On the negative side, 0.22 points me to 0.4129. On the positive side, 0.067 points me to 0.7486. To find my between, I do 0.7486, the larger one, minus 0.4129, the smaller one. When I put that into my calculator, 0.7486 minus 0.4129. That's how I get the correct final answer of 0.3357. Again, it tells you to round to 4 decimal places, so that's what I'm going to keep it at. For the final problem here, find the necessary confidence interval for a population mean mu if it's a 95% interval where n equals 81, x bar equals 17.1, and s squared equals 5.25. First thing I need is my equation for the margin of error. So the margin of error, or as I call it, the MOE, equals z alpha over 2 times sigma over the root of n. Or in this case, since we have it from a sample, s over the root of n. This was very confusing for a lot of students because I didn't go over it when I did the video the first time. Apologies, but really I need to be careful because they've given me s squared, but the formula calls for s. So when I'm doing this formula, I start by saying z alpha over 2. What's the proper one to use for 95%? There's only 3 to memorize here. When we're doing 90%, it's 1.645. When we're doing 99%, it's 2.575. So here, when we're doing 95%, it's 1.96. When I say memorize, I really should just say write on a paper. On your paper, when you're doing this test, you should definitely have the 3 key 95, 90, and 90% z alpha over 2's. I then need to plug in s, but I don't know s yet. I know s squared is 5.25. So I need to take the square root of 5.25, which they tell me is 2.29. So I'm going to put here 2.29. I'm going to divide that by the root of n, in this case the root of 81. So when I put into my calculator 1.96 parentheses 2.29 over the root of 81, my calculator tells me the margin of error is 0.4987. Depending upon how many decimal places it asks me to go, I would want to round this. I believe this only asks me to go to 3 decimal places, so even then, it really rounds up to 0.500. I've now found how far I want to move in each direction. What I need is a starting point. This is my starting point. X bar is the mean that we begin at. That's my best guess for the middle of the region. Then I'm going to move margin of error either way from that. What's going to end up happening then is I'm going to have an interval that starts at my X bar, in this case 17.1, minus my calculated margin of error 0.5, and then starts at my X bar 17.1 plus my margin of error 0.5. It always must be the case that it's smaller number and then larger number. So here I get 16.6, comma, 17.6 as my final confidence interval. And what that really tells me is in repeated sampling, 95% of the intervals created this way will contain the true population mean.